So in this section we're going to talk about marginal cost, marginal profit, and marginal revenue. So suppose that you have a cost function. So this cost function is going to give you the cost of producing X units. Then something you would be perhaps interested in finding out is what is the cost if you're producing, say, 100 units, what would be the cost of producing one additional unit? So for example, if you have X and you want to go to X plus 1 units, so what is that cost of that one extra unit? So for example, the cost of X plus 1 units minus the cost of 1 unit. And if you think about it as a slope of a secant line, then here you would have an X plus 1 minus X, minus 1 plus 1 minus X, which would be equal to the cost of producing X plus 1 minus the cost of producing X units. And that then, if you look at this expression, this can be approximated, this is the slope of a secant line, can be approximated by the slope of the tangent line. So this, the derivative of the cost function at X, is going to tell you roughly what is the cost of going of producing one extra unit once you're at a level of production of X units. So this is going to be called the marginal cost. And similarly, you can define the marginal revenue. And you can also define a marginal profit. So let's do a little example and see how this works. So let's assume we're given a revenue function. So let's say we have a revenue function in terms of x being something like 100x minus x squared. So this is going to be just a parabola and has intercepts 0 and 100, and then you have a, well, if I could land in that spot would be wonderful, and you have a parabola, and then let's say you have a cost function. This cost functions often will be linear functions, so you have a fixed cost, let's say $400, and then you have a variable cost of, say, I don't know, $2 per unit, so we have plus 2x. So that could be a scenario where you could have that. Let me erase my ugly picture. And so let's say we want to find out what would be the revenue when we're selling 30 units, for example. Well, if we want to find out the revenue at 30 units, we would have to plug it in our calculator. So, and then minus, that's how I do squares in this calculator. And what do we get? We get $2,100. Okay, so if you want to find the cost at, say, when you sell 30 units or produce 30 units, you would have, almost didn't fit it, 400 minus, or plus, sorry, 60, so it would be $460. And we know that the profit will be the cost. Profit, and I wrote revenue. So let's write profit is the revenue minus the cost. So the profit at 30 would be revenue at 30 minus the cost at 30. In this particular case would be 2,100 minus 460. Alright, so the question now is, well, how is the revenue increasing when you go from 30 to 31 units? So what is our marginal revenue? Ultimately, we would want to know what is the marginal profit, because that's going to tell us if our profits are still increasing as we increase the production, or if we are actually going down. So that would be the important part. So let's look at the revenue. So that would be, let's do it at 30 units. So we would like to take the derivative of the revenue, which is right here, 100 minus 2x. And I want to say we're going to evaluate it at x equals 30. So I just took the derivative of my revenue function and I evaluated. So in this case, the revenue is increasing by 100 minus 60, which is going to be $40. So this is telling me that the revenue is increasing. So revenue increasing at a rate of $40 per unit when we are selling, or sales are at 30 units. So what about the marginal cost? Well, we do the same thing. Marginal cost would be the derivative of the cost function, and we evaluate it at 30. Derivative of the cost function is just 2, so we don't even have to evaluate it. It's already evaluated. So that's telling us that the cost is increasing by at a rate of $2 per unit. So you see your marginal profit will be 40 minus 2, which is actually going to be $38. So let's write out this. Cost is increasing. By the way, if you would get a negative sign, what that would be telling you is that the cost in that case would be decreasing. Cost, you don't expect it to be decreasing, but the revenue may start decreasing at some point. All right, so our marginal profit, that's going to tell us how is the profit either increasing or decreasing at our level of production. So in this case, the profit, and I realized I did not write the expression for the profit function. So what I'm going to do is, since profit is just revenue minus cost, when I take the derivative, since the derivative is linear, I can just take the derivative of each term. Now, if we had a product, we wouldn't be able to do that, but since it's a sum or a difference of it, we can certainly do it. So in this case, it's just going to be the revenue, marginal revenue, minus the marginal cost. In that case, then it's going to be 40 minus 2. So our profit is increasing by $38 per product. We profit quite a bit per unit. So this is going to be dollars per unit, by the way. I did not write that here, and I should have. So just add that per unit, because we're doing the derivative with respect to the production, with respect to x, which is the number of units produced. So you get per unit. All right, and that's pretty much the idea of this. You could certainly, in this particular case, you could have written this function explicitly. Would have been just 100x minus x squared. Oops, x minus x squared. minus the cost function. But in the end, you could have done it this way as well. So you choose which is the way you prefer. I think this is easier. So just let me know if you have any questions.